Hello and welcome to Physics Tips for Cambridge Students YouTube channel. And in today's video, we are going to be looking at ideal gases and specifically looking at the mole. Now, the learning outcomes. Understand that amount of substance is an SI-based quantity with the base unit, the mole, and also use molar quantities where 1 mole of any substance is the amount containing a number of particles of that substance equal to Avogadro constant. Now remember to subscribe to the Physics Tips for Cambridge Students YouTube channel and hit the bell notification so that you get alerted of future videos. Without much further ado, let's get started. Now, when comparing gases, it is convenient to work in molar quantities. The mole is the SI unit of the amount of substance. It is not a unit of mass. 1 mole is the amount of substance that contains as many particles as there are carbon atoms in exactly 12 grams of carbon-12. The number of particles in 1 mole is called Avogadro constant, and the symbol is N subscript A. Avogadro constant is defined as the number of atoms of carbon-12 in 12 grams of carbon-12 equal to 6.02 times 10 to the power of 23 per mole. So in 12 grams of carbon-12, there are 6.02 times 10 to the power of 23 atoms of that element. And in sodium, 1 mole of sodium contains the same number, that is 6.02 times 10 to the power of 23 atoms of sodium. The number of atoms can be determined by multiplying the number of moles by Avogadro constant. For example, 2 moles of nitrogen contains 2 times 6.02 times 10 to the power of 23 atoms, which gives you 1.20 times 10 to the power of 24 atoms. Now, 1 mole of any element is equal to the relative atomic mass of that element expressed in grams. For example, helium is an atomic mass of 4. This means that 1 mole of helium has a mass of 4 grams. Water is made up of 2 hydrogen atoms and 1 oxygen atom. So the atomic mass of hydrogen is 1 and the atomic mass of oxygen is 16. So 2 times 1 for 2 hydrogen atoms and 1 times 16 for the oxygen one. So it will be 2 plus 16 giving you 18 grams. The molar mass of a substance is the mass of 1 mole of that substance. The unit is the kg per mole. E.g., the molar mass of oxygen would be 32 grams per mole. Remember, oxygen exists as a diatomic molecule, so it will be O2, hence 16 times 2, giving you 32. And converting that into kgs gives you 0.032 kgs per mole. So 0.032 kgs of oxygen contains Avogadro number of oxygen molecules. The number of moles from this can be calculated using the equation number of moles is equal to mass over the molar mass. Now, the number of molecules in the mass m of a substance will be equal to mass over molar mass, which is number of moles, times Avogadro constant. And the relative mass of a substance is the mass of a molecule fit compared with 1/12 of the mass of an atom of the carbon-12 isotope. It is a pure number without any units. So since relative means a ratio. Now let's define the atomic mass unit. By definition, 1 atomic mass unit is 1/12 of the mass of carbon-12. So a mole of carbon has exactly 12 grams, which contains 6.02 times 10 to the power of 23 atoms. So it means the mass of 1 carbon-12 atom will be the mass over the number of atoms in 1 mole, which is 6.02 times 10 to the power of 23. That gives you 1.993 times 10 to the power of minus 26 kgs. So 1/12 of that would be 1 atomic mass unit, which is 1 U. So 1 U is 1 over 12 times 1.993 times 10 to the power of minus 26. If you do the maths there, you get 1 U equals 1.66 times 10 to the power of minus 27 kgs. Now let's work out some examples. The first example says calculate the number of atoms in and the mass of the following: 3 moles of water, 1 mole of ozone. Now, looking at water, remember we have just said that water consists of 2 atoms of hydrogen and 1 atom of oxygen. We are going to say 2 times 1 plus 1 times 16. So 1 mole of water will be that. We're saying the 3 atoms, now we're multiplying by 3 because of the 3 moles. That gives you 3 times 18.06, giving you 5.42 times 10 to the power of 24 atoms. So 1 mole of water is a mass of 18 grams. 3 moles will be 3 times that, which will be 54 grams. Then moving on to 1 mole of ozone. Now 1 mole of ozone has these numbers, that is Avogadro number of atoms, which means that ozone will be 3 oxygen atoms, which will be 3 times that number, giving you 18.1 times 10 to the power of 23 atoms. So the mass of ozone in 1 mole will be 3 times 16, which is 48 grams. Example number 2. The mass of 1 mole of hydrogen gas is 2 grams. Calculate the mass of 1 hydrogen atom. Right, so 1 mole of hydrogen contains 2 times this number. Remember, hydrogen again exists as a diatomic molecule, so that's going to give you 2 times that, which gives 12.02 times 10 to the power of 23. Now, to get the mass of 1 hydrogen atom, we are going to divide the 2 by 2 times that, which is going to give you 1.66 times 10 to the power of minus 24 grams. I'm going to end the video here. Please remember to subscribe to the Physics Tips for Cambridge Students YouTube channel and hit the bell notification. Signing out.